This is a continuation of lecture 6-2. This is the second part of 6-2, where instead of giving an x and looking for a percentile, you're actually given the percentile and you're looking for the x value. So this is the backwards problem. In algebra, we call it an inverse function, and this is exactly what it's called on your TI-84 calculator or TI calculators. So the example is 6-9. I'm looking at 6-9. To qualify for Police Academy, candidates must score in the top 10% on the general ability test. Assume the test scores are normally distributed and the test has a mean of 200 and a standard deviation of 20. Find the lowest score possible to qualify. So they gave me a go-ahead to use a normal distribution. They told me that the scores are approximately normally distributed with a mean of 200. So they told me that the mean is 200 and standard deviation of 20. What they're interested in is the top 10%. Now, if you have a top 10%, that means that on the bottom you have 90%. The way the inverse function works on your calculator is it cannot calculate top percentile. It will only calculate bottom percentile. So under distribution, you will find a function that's called inverse norm. It should be the third. If you have a drop-down menu in the TI-84, you will type in your area, which is the bottom area of the x that you're interested in. So we're looking for the bottom 90%. It will also prompt you for mu, which is 200, and a sigma of 20. If you paste this, you will get to a TI-83 menu. So the inverse norm is calling out for the bottom area, the mu, and then sigma. If you push enter, it will give you 225.6. If these are scores, maybe there's decimal, maybe not. So we'll leave it like this. So apparently the score that we need of 226 points. We'll assume that there is no half points. Let's take a look at another problem, which is 6-10. For medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. Assuming that blood pressure readings are normally distributed and the mean systolic blood pressure is 120 and a standard deviation is 8, find upper and lower readings that would qualify people to participate in the study. So secretly, this problem has two parts because we're looking for the middle 60%. So what we'll have is we'll have a lower bound, which is part A, and we'll have an upper bound, which is part B. So they gave me a go-ahead to use a normal distribution, so I'll draw my little curve. They also told me that the mean is 120 and the standard deviation is 8. What we need is we need a middle 60%. So we're looking at this. If we're looking at middle 60%, that means that the other 40% I'll split into two tails. So the little pieces we're going to be calling tails for the rest of the semester. So if I have the other 40% split into two, that means that this tail, my right tail is 20% and my left tail is another 20%. This is going to be my x1, which is the lower bound. This is going to be my x2, which is an upper bound. Just by looking at the graph, I know that my x1 is below 120 and I know my x2 is above 120. That's about it. I can also take a look at the standard deviation, but we'll take a look at this in a second after I finish this particular example. What we need is an inverse norm. The inverse norm is asking for the bottom percentile. So in order for me to find x1, the lower limit, I need to tell my calculator that I'm looking for the x that separates the bottom 20% from the top 80. So I need bottom 20%, comma, mu, comma, sigma. Distribution, inverse norm, 0.2, 128, paste, and what I'll have is 113.3. So if you want to round to the whole number because it makes more sense, we'll do that in a sentence. In order for me to find x2, so this is x1, in order for me to find x2, I need inverse norm. And in order for me to separate the top 20%, that means that on the bottom I have 80%. So inverse norm is calling out for the bottom area, 80%, and then you'll have your mu, you'll have your sigma. Distribution, inverse norm, the bottom 80%, and after I paste this, I should get 126.7. This is my x sub 2. So, in a lot of the times from here on, your final answer should be a sentence. So, for this particular sentence, we're looking for people to participate in a study. So, people who will participate in this study will have a blood pressure, and now you round between 113 and 127. If we know the units, that would be awesome. If we don't, we don't. I don't see any units, so we'll put a period. Now, what I wanted to point out, so I'm done with this problem. What I'd like to point out is the empirical rule. Now, the empirical rule, we just touched upon it before, but if you recall empirical rule, what it tells me is if you're one standard deviation away from the mean, you are at 68%. What I wanted to show you is how to get this on a calculator. So you're at 68%. So if I look at my standard normal curve and let my mu to be 1, mu to be 0 and sigma to be 1, you can actually look up the 68% on your calculator. If you click on distributions, normal CDF, You'll put your lower limit. So if this is your 0, you go to the left, you go to -1. You go to the right, you go to a +1. So if you go between -1 and 1, 0, 1, so -1, 1, 0, 1, you push enter and you actually see this coming up at 0.6827. So the approximation of 68% was just an approximation correct to 2 decimal places rather than 4. But the empirical rule is a special case of a normal distribution or applications of normal distribution. So if this makes more sense, that's great. On the next video, I'll just quickly show you how I did this on a calculator, and that should do it for 6-2.